I had I had more than one parent who came in and said, "I'm supposed to be here because we're supposed to buy a puppy now." So that was cool. Um, it is kind of the good and bad. Normally, I actually really like parent-teacher conferences because I get to just BS with parents, and I'm a blabby person. Um, and 9 times out of 10, it's a good conversation with them anyway, where they're just, hey, this is the stuff we do in class. This is the stuff they can do if they want to get a little bit better. But they're doing great anyway. The 10th time out of 10, it's someone who isn't doing diddly. And I show them everything that we have in class. You get the review. It looks like the quiz right before you do the quiz. It's open notes, open everything. And then they look at their kid like this. Yeah. Oh yes. I've seen parents just lay into the kid, and I'd try to stop them, like, "Whoa, okay, the horse is already dead. Just chill. We know this is bad. How do we fix it?" But yeah, I saw one kid in between two parents, and he just kept getting slower and lower and lower in his seat. Like, hey, freshman, you know what I've been telling you for 3 weeks that I'm going to say all this to your parents, and then they're going to come in, and then they're going to look at you like this, and they're going to commit murder? Didn't I say this exact thing was going to happen? Yes. So, but no daily quiz. I can't think right now, so I can't even make a daily quiz up. So, um, but no, normally conferences are great, but within a week of conferences every year, sinus infection because everything's dead and dying outside. So that just kind of icing on the cake. So yeah. Well, we already did the basic stuff about the polynomials. Yesterday was more about the calculator mojo. And then today we do remainder theorem. Next week we get hard on like the actual solving polynomials. So I'm not worried about this stuff right now. Because you're reviewing the entirety of chapter 5 from algebra 2, which took us a month. So, I did not see any questions until like 8:45 when the last parent left my room. So if you have any questions, speak now or forever hold your pieces. Because they were parents that I wanted to talk to. Like, I don't care. 7:30, I'm like, my kid's already in bed. Bring it. So, nothing? Well, nothing? Were we okay with the calculator business? That was a lot of calculator business. Okay. All right. Then we ended class yesterday with a trip down memory lane. Long division. Okay. The idea was long division is algorithmic. If I say 438 divided by 6, does 6 go into 4? No. Does it go into 43? Yes. So I say 6 goes into 43 7 times. What do I do with that 7? Multiply it by 6. Okay, so you multiply and then you subtract. That is important. Subtracting is changing the signs. It's adding the opposite. And then what do I do with that 8? You drop it. It's a little hot. You say, now I got an 18. And then you start the process over again, right? So some famous dead dude, long time ago, figures out, wait a second, I can do that with polynomials. Because if I can take 6x squared plus 3x minus 9 times 2x minus 1, if I can multiply that longhand, just like old multi-digit multiplication, 9, negative 3x, negative 6x squared, 0 as a placeholder, and you keep going. If I can do this with multiplication, because it keeps everything lined up by place value. Place value is just, because isn't this x to the third, x squared, x to the first, x to the 0? Well, that's still place value. That's 10 to the third is the thousandths place value, is the hundredths place value, is the tenth place value, is the ones place value. So they recognize this correlation. Yeah, I know there's coefficients there. They... What? Oh. Okay. Okay, here's what I'm gonna do. I have slept a total of 16 hours this week. Okay, there's your 3. Leave me alone. Okay. There's your 3. Leave me alone. What? We don't use that language in my room. So, old dead dude figures out all of these polynomial descending order of degrees are set up just like place value. Whenever I do longhand multiplication or division, I keep everything lined up by place value. So that means I can divide the same way that I do with regular numbers with polynomials, because it keeps it organized for me. That's a really dead pencil. Yeah, there is. So, I'm going to take 6x to the third minus 25x squared plus 18x plus 9. And I'm going to divide it by x minus 3. Longhand. Now you're always looking at the first term of your, who remembers the terminology? The thing you are dividing by is called a what? Divisor. Yes. What is the thing you are dividing up? Dividend. What is the answer of division problem? Quotient. Okay, just checking. So, stage 1. You take your first term divided by always the first term of your divisor. 6x cubed divided by x is 6x squared. They will not always go in evenly. You might have a fraction up there. That's okay. And then I multiply, but I have to multiply by the entire divisor. 6x squared times x is 6x cubed. 6x squared times negative 3 is negative 18x squared. What did I do after the multiplication thing? You subtract. So if I subtract this whole thing, it's going to change all the signs. So I just change the signs. If you want to say minus and then parentheses, go for it. I just change the signs. Okay? This will cancel out every time. That's the purpose of this. Negative 25x squared plus 18x squared is negative 7x squared. I take the next term and I drop it because it's a little hot and say 18x. Do it again! Okay, how many of you were actually like humming MC Hammer while you were doing your other quizzes, though? -4, can't touch it. Okay. -7x squared divided by x. It's always by the leading term. -7x squared divided by x is a -7x. This divided by this. So now when I take -7x squared times x, I get -7x squared. All right, that was supposed to be a square, and you all got me rattled now. Okay, take a -7x times the -3. I get a positive 21x. And then I subtract that thing. I'm getting there, right? I did this times that. I got this. Now when I subtract it, okay, you can show this if you want, right? Subtract the thing. I don't want to subtract the thing. Instead, I'm just going to change my signs. Like that. Now that's me, personally. If you want to show the parentheses and subtract the thing, subtract the thing. And I got 18x minus 21x is a -3x. Drop it. It's a little hot. And do it one more time. -3x divided by x is, where's my next color? There we go. Is -3. So if I take -3 times this stuff, I get -3x plus 9. Change your signs. Change, change, 0. What does it mean if I get a 0 at the end? No remainder, so what's that called? I can now say that x minus 3 is a what of this polynomial? A factor. Because it goes in evenly. Just like 5 is a factor of 15. Right? Because 15 divided by 5 has a remainder of 0. So x minus 3 is a factor of this polynomial. That also means because I took this divided by this and got that, I can write now, if I want, it doesn't ask us to, but it's going to later. I can now say that x minus 3 times 6x squared minus 7x minus 3 is that polynomial. Just like I can say 2 times 12 is 24. Because 24 divided by 2 was 12. Okay? But you have to run through that process. This is now the third class that you have done that in. You first saw it in Algebra 1. So tell me, do you need to see it again before getting set loose? Yes? No? All right. Then we'll start with, oh no, we're going to do both because there's a thing. We're doing both because there's a thing. There is plenty of room. We got a kid. On. Just, yep, okay. That's why the proper response is always Christ compels you. Oh, when you do it to random strangers, they kind of get weird. Someone just sneezes as you're walking by in the mall, and you say, "Get back, demon!" Although in the quarantines, that's kind of a valid response anyway.
When can I start doing synthetic division?
You have to know long because synthetic only works with linear factors.
Oh, yeah.
There is a way that you can work with the twos, yes. Go ahead and run it into the end zone, see what happens. See if you get the same thing. Do x cubed divided by x. It's x squared. Take x squared times the stuff, change the signs. Drop the 4x, it's a little hot. And say x squared divided by x is just an x. X times the stuff is x squared and 6x. Just like before, change signs. Get a negative 2x, drop the negative 12, it's a little hot. Say negative 2x divided by x is orange. Negative 2. Negative 2 times the stuff is a negative 2x minus 12. But when I change my signs, when I subtract it, bye-bye. Okay. Now, the next one. I'm kind of sensing a pattern here. Whenever there's a thing you can do, Paul normally calls it out. Wait, can I just this first? You're right. I'm dividing, right? I'm taking a polynomial and dividing it by a divisor function to get a quotient function. Well, whenever I take a thing over a thing, what happens if they both have something in common? Look at everything in the dividend, look at the divisor. Every single term is divisible by 2. So both ways work, right? Just like I can take 168 divided by 8, I can also take 42 divided by 2. Right? Like if I take both the dividend and the divisor and divide them both by 4, it's still going to give me the same answer. Same thing's going to happen here. So it's your choice. What? No. I'm saying it's going to work both ways. Yeah, no. Bad. So if a bunch of you did this divided by that, great. If someone else came along and said 3x to the third minus x squared minus 8x minus 4 divided by x minus 2, you would still get the same thing. Okay. Let's double check it. See if we can speed run. 3x cubed divided by x, 3x squared. 3x squared times the stuff. 3x to the third minus 6x squared. Change your signs. Get 5x squared. Drop it, little hot. Say 5x squared divided by the thing. Get 5x. 5x times the stuff. It's 5x squared minus 10x. Change your signs. No, no, yellow. Get 2x minus 4. Divide. Get 2. 2 times the stuff. 2x minus 4. Change your signs. Isn't that the same thing you got if you didn't take the 2 out? Okay. That's going to be important when we hit synthetic division. It is going to be important when we hit synthetic division. No, it's just now I like to do it.
It's fun.
Well, no, when I ask students and I have, like, say 18 kids say, I don't really care. But then I have the 2 kids who say, no, that's better. I'm just going to do it. Because if the other ones don't care and these ones, it makes more visual sense tracking. Okay. So this is just the algorithmic version of it, showing you the process to dividing them. You come down here, I kind of already said it. Can you read that in Mathese? A function divided by a divisor function will give me a quotient plus, what do you think? A remainder over divisor. Just like we kind of said this yesterday, and then Paul erased my 1. If I have that, we see it doesn't end in a 5 or a 0. I know this is going to have a remainder, right? 43 divided by 5, 8. 40 subtract 3, drop 6. 36 divided by is 7, 7 by thing. 35, I probably could have made this shorter. 2, divide that and get 2, get 10. 2, drop it, little hot. Take that, divide by that, get that, and then get 25, and then we subtract, and we get 4, and we get 8, and we say 9, and then we get 45, and then we get, crap. We don't say remainder 3, because we're not in 3rd grade. In 4th grade, we learned and 3/5, right?
I was doing remainder. We were doing remainder.
Okay. Or you probably did the point, add a bunch of zeros and keep going. But they told you to stop after a certain point, which means you lost part of your answer. We've talked about round-off error in here before. What happens when you have, okay, now in this case it's a terminating decimal, but what happens, the difference between I'm supposed to be paid $11.25 an hour versus I was paid $11.20 an hour? You're like, it's a nickel. Who cares? Y'all got a calculator? What's a nickel times 20 hours a week times 40 weeks in the school year? Should be 40. Okay. But $40, that's the difference between they stole $40 from me and not. That's the difference between I get a new game and not. Right? Just because they rounded off. You lost part of your answer. You don't want to lose part of your wage. So, don't lose part of your answer. Write it as a fraction. Now I got this just mental image of Lindsay coming up to someone and be like, yo, give me my money. So, if I'm going to divide, there are things that I need to keep in mind that I also kept in mind with regular digit division. Stop beating me to the punch, okay? When I do this, I am going to get, when I do this, I'm going to get the wrong answer. Just like if you picked up your paycheck and instead of saying $208, it said $28. That zero is a placeholder for a reason. It matters. So just like you need a placeholder there, you better put a 0x squared here. You have to put the placeholder.
Oh, I remember that.
I see kids year after year after year, some of the smartest kids in the room, get that 1 or 2 points off on the dividing problem because they just didn't put a placeholder. Okay? Now you're good to go. 9x cubed divided by 3x is 3x squared. Multiply. 9x cubed, 6x squared. Change your signs. Shoot, shoot. Drop your negative x, a little hot. Say negative 6x divided by 3x, or 6x squared, sorry. I'm going to get negative 2x. Negative 2x times the stuff is negative 6x squared minus 4x. Change your signs. Shoot, shoot. Getting 3x minus 3. And it's so close. So close. We get 3x minus 3 divided by, well, 3x plus 2. I got just a 1 and get 3x plus 2. Change my signs, and rut-row raggy, you got a remainder. So you put remainder over divisor. At the end, minus 5 over 3x plus 2. Yes. Yeah, everything for the next like 3 days is going to be just review of chapter 5.
Would it be wrong if we said plus -5?
Okay. There is no such thing as subtraction. There is only add the inverse, right? So, yeah, you're right. Both are good. So, if you get a remainder, you can write the remainder correctly. If you need a placeholder, you got to put a placeholder. Let's start with 2a.
What's up?
The guy who sounds like Tom Holland having a flash drink cup is just so wrong. Yeah.
What is it? Synthetic division where you have to change the sign?
Yep.
Okay.
Well, it's not like change the sign, it's actually the 0 of,
Yeah.
and that's going to be important here when we get to it.
I thought you Yeah. Yeah, I don't know. My dad bought these. He had a bunch of superhero ownable ones. No, but I should invest in the Spider-Man one.
Invest.
Make it your vibe, dude.
Totally.
Just
I need to invent the.
go find one of those Spider-Man kitty backpacks. Get a lunchbox.
I'm just gonna wear a Spider-Man suit everywhere I go. From head to toe.
I think Anna might get a little uncomfortable if you show up in spandex, though. See, I incite these things because if I'm awkward all the time, I'm going to make other people feel awkward. We take 8x cubed divided by 2x. Got 4x squared. Multiply it. 8x cubed minus 12x squared. Change your signs. Do negative 18 plus 12 is a negative 6x squared. Drop the 21, little hot. Take negative 6x squared divided by 2x. Negative 3x. Negative 3x times the stuff is negative 6x squared plus 9x. Change your signs. Okay, this is just a little thing that I do. It doesn't have to be a thing that you do. Because that's a positive 9x right now, and I know that I'm going to have to change the signs, I won't put the plus there. Because then like you end up like scribbling the negative on top of the plus. But like if I'm changing the sign on something that's negative, it's easy to just do this, as opposed to scribbling a negative on top of a positive. It's a little thing. It might help, it might not. And I say, here's a 512x. Drop it. What? And say 12x divided by 2x. 6x, or 6. 6 times the stuff is 12x minus 18. Change your signs. Shoop, shoop, shoop. Now what? Okay, so it's either plus a negative 2 over, or you can bring the negative out front, like that. Both of them are correct. Okay? No, fractions. That's what I said. It just gets ugly. Uh-huh. Let's back that math up. And let's say it's a really good question. Let's say we have this. Okay, I still 8x cubed divided by and get 4x squared times the stuff, 8x cubed minus 12x squared. And then when I change my signs, shoop, we got a negative 3x squared plus 21x. You're not saying how many times does this go in here. You're saying negative 3x squared divided by 2x. So cancel. Negative 3 halves x. And then distribute it. Getting negative 3x squared plus 9 halves x. Change the signs. 21x is really 42 halves. 42 halves minus 9 halves is 33 halves x. Drop it. But you keep going, right? Actually, I want to run this to the end because I want you to see what the remainder does. 33 halves divided by 2 is now 33 fourths. 33/4 times all of this mess. 33 halves x minus 99/4. Okay. Negative 20 is really negative 84th, so now this becomes 19/4. Plus 19/4 over 2x minus 3. But now, okay, this is why I wanted to run it to the end. This is a compound fraction. Compound fractions are ugly. So, dividing by fractions is easy as pie. When I run into this now, I have 19/4 times 1 over 2x minus 3. So this isn't my remainder. This is. I'm glad you asked the question because it will pop up. The majority of our problems are all integers. You will run across this.
You should tell us at what point.
I don't remember. No, I wouldn't. No. In fact, when I do the quizzes, I always make sure that the ugliest problem is on the review, not the quiz. So, like, no, the quiz is supposed to be like sea level, middle of the road. Can you do the thing that we did? Not the now I shall challenge you and put it in the grade book. Like, no. The challenge is to expand your learning and your understanding of it, not to get you. Okay? I think we're cool with that one. I want to instead, there we go. So, Andrew
Yes.
kept saying, can we just do synthetic division? Synthetic division only works with linear factors. What happens when you have to divide by a quadratic or cubic or quartic factor? No. You still have to be able to do it, and that's why we're practicing the longhand division. Now, in the past, I did make a, like, it's not a thing, but I made a bastardized hybrid between synthetic and long division for higher order polynomials, and it worked. It cut the time down in half. I showed kids, they kind of liked it, but then I never showed anyone else again because you're never going to see it anywhere else. I just made it. Like, no other teacher will ever know what the hell this is, and it might just confuse you later, so I just stopped showing kids. So just know synthetic for linear, long division for everything else. There is a synthetic division for higher order polynomials that I think you learn in Calc 2. Yes.
So on the homework, you use synthetic for those.
If it's linear, yes. You got to know how to do both because what happens when I'm dividing by a quadratic? Okay. 2x to the fourth minus 4x to the third. Womp. It's still the same deal. Yeah.
Just a question. Could you take the divider? I think. Yeah. Could you take that and break it up and then just divide it twice?
If it's factorable. If it's factorable. In this case, you have negative 7, 1, so 5, negative 6. It's going to be 1 plus or minus root of 6, I. Those are your two roots. Do you want to do synthetic division with x minus 1 plus square root of 6, I? So that's why we have to know how to divide by quadratics longhand. To avoid this. So it's still the same process. 2x to the fourth divided by the leading term, x squared. And it goes above x squared. X squared goes above x squared. Then take that times all of this junk. 2x to the fourth minus 4x to the third plus 14x squared. Change your signs. Now in this case they're being nice, the first two terms canceled. Doesn't always work like that. So it cancels, I get a negative x squared. Now when I'm dividing by a term that has 3 terms. So what am I dropping? And then negative x squared divided by x squared. Negative 1. Negative 1 is a constant. Where should I write it? And then, if we have to do the 0 x to the third and then run that, like I could have said 0 x to the third here, and then said 0 x to the third divided by x squared is 0, put a 0 here, take a 0 times all this crap. I could do that and have an entire section here full of zeros that doesn't change and still gives me blue. Like you can do that, it's not necessary. Negative 1 times the stuff is negative x squared plus 2x minus 7. Change your signs. Change the signs. Getting x minus 4. So my answer has an entire plus x minus 4 over x squared minus 2x plus 7. If you get an x minus 4, say that was x minus 4 over x squared minus 2x plus 8. X squared minus 2x plus 8 factors into x minus 4x plus 2. I would have been able to cancel something out, right? If that happens, that means you could have reduced the original and the divisor before you started. Okay?
So does that mean it's wrong, or what do you do?
You would just reduce this.
Okay.
What you have is correct, but you missed an entire factor at the beginning. Yeah.
Is it plus 8 or plus 7?
No, I'm saying if this happened.
Oh, okay.
Okay. So, mind your zeros as placeholders. When you get your remainder, it's remainder over all the mess. We'll see how 3B goes. You growl at me.
Oh!
Got a 0 squared.
You get X out like Paul said. I was just
I like how Paul comes up with
Hmm? Paul's a thinker. He sees the thing before we get to the thing.
10 hours of sleep in a week. Cut it out.
Yeah. Today's just, I need to make it through the day, so it's all caffeine and drugs. Yeah, and then I had a sinus infection in a week that I had 16 hours of sleep. Which is also how all of this came to be in the first place. Baby Bear didn't let me sleep for more than 3.5 hours a night for 7 months. Look forward to children. I mean, Baby Bear didn't let me sleep. The first child slept unconscious 7 p.m. to 7 a.m. You could poke him with a stick and he wouldn't move. It was great.
You're like baby bear or whatever.
Okay, first I thought Paul was a thinker. Now he's back here like, give him a shot of whiskey, like Grandpa. So, now, I'm just going to run with this as it is until we see the thing at the end so you understand that this still works. If I have 6x to the 5th minus x to the 4th plus 0 x to the 3rd plus 12x squared plus 15x, did we remember that? Divided by 3x to the 3rd minus 2x squared plus x. Stage 1, 6x to the 5th divided by 3x to the 3rd. 2x squared, way over there. 2x squared times the stuff. 6x to the 5th minus 4x to the 4th plus 2x cubed. Change your signs. Shoop, shoop, shoop. First one cancels out. Second one, 3x to the 4th minus 2x to the 3rd, and I will drop a single term so that I still have 3 terms, 3 terms. 3x to the 4th divided by 3x to the 3rd, uno x. X times the stuff. Get 3x to the 4th minus 2x to the 3rd plus x squared. I'm about to turn around and yeet you out of the room, Andrew. Okay. 12x squared minus x squared, contrary to freshman ideas, is 11x squared, not 12. Well, yeah, 12x squared minus an x squared is just 12, right?
Yeah. Math rules. That's a nice little thing.
Now, look at what happens here. If I take 11x squared divided by 3x cubed, this won't go into that, right? You'll have an x on the denominator. That means I have hit the end of the rainbow. Yeah? Not going to change its value. Since x squared over x cubed results in x on denominator, I know that I've hit my remainder. But if I write 11x squared plus 15x all over 3x to the 3rd minus 2x squared plus x, look at what I can still do with the remainder. I can reduce it by an x. So 2x squared plus x plus 11x plus 15 over 3x squared minus 2x plus 1 is my final answer. I was able to reduce that, right? Now, did anyone take the x out of here and here at the beginning? Still got the same answer, right? But here's the difference between when I'm trying to find zeros versus I'm trying to find functions. If I'm trying to find a zero, it's possible to have a graph in which this is what you should get, but by reducing it, you actually end up getting, oh, no, backwards. That. That's the difference between I left the 2 there, red, I reduced by 2, blue. They have the same zeros, right? They still have the same x-intercepts. But the resultant function is going to be half as tall as the other one. That's going to be important when we hit synthetic division here to know that even though they both resulted in the same answer, can I say this times this is that? Okay. Because way back here, I reduced down the x, only in the remainder. Whereas when you divided by x at the beginning, you didn't divide by this, did you? You divided by 3x squared minus 2x plus 1 times all this stuff. So now, when I multiply it out, do I get the original function? Exactly. That's the only difference. They still get the same quotient. But if you reduce that x at the beginning of the problem, to write the factorization of it, you need to say that x is there. But if you reduce that x at the end in your remainder, well, then everything's good. It's a tiny nuanced thing, but it's going to matter when we're trying to find large polynomials from imaginary roots. It's a thing that matters later. So it's better to just say it now while we got a problem in front of us. And then the Savior comes down from the mountaintop and says, have I got a deal for you? Synthetic division. Synthetic division. Someone along the way notices, hey, if I just keep everything in place value, the x's don't even matter. What? No? That's sign up for card tournaments, dude. Like, did he just notice the clipboard is there like 6 weeks later? All right. Some famous dead dude looks at this and says, hey, I don't even need the x's, right? Everything's just going to line up anyway. What I do have to pay attention to is every time that I did this, I always subtracted, right? If I'm always subtracting, isn't that adding a negative? So couldn't I just negate a thing? And they develop synthetic division that says I'm going to get rid of all the variables. So long as I keep them in descending order, they're in place value. If they're in place value, I don't need the variables. And instead of using -3, and I got, well, what do I do there? Does it actually work or not? I want the 0 up. I want, where is it? Right here. It's not, when I divide by this, it's not just change the sign. It's the 0 of. of the factor. Now that's important because what happens if I'm dividing by 2x minus 3? I don't just put 3. What do you put? 3 halves, the 0 of the factor. Okay? And you just keep multiply and add and multiply and add and multiply and add, and it makes these go so much faster. I start by writing out all my coefficients with a 0 as a placeholder when I need it. Now, it depends on the book. Y'all tell me, like, some of you had me for Algebra 2. I was always taught this, like, literally take the division sign and flip it. Other people are taught to put, like, a little box right here instead.
Yeah, that's what I did too.
Okay, do it however you're gonna do it. I don't care. I don't like the box because now I have 2 things floating there. Particularly when I keep dividing. When you keep doing synthetic division in a chain, that's why I like this. You know, when you take a quintic and divide it, now it's quartic, divide it, now it's a cubic, divide it, now it's quadratic, throw it in quadratic formula. That's why I like this. That's me, doesn't have to be you. So, but if everyone thought like me, then I'd be normal. Huh. Okay, throw what goes over here? The 0 of, and you still drop it like it's hot. Then go on down the road. It's multiply and add, multiply and add, multiply and add over and over. I'm going to take -2 by 2, get a -4, 0 plus -4. -2 times -4, getting +8. -5 plus 8 is 3. -2 by 3 is a -6. 5 minus 6, -1. -2 by -1 is 2. Add them together, 0. And then my answer, I have to keep in mind what I just divided by. I took a quartic and divided it by x to the first. So what should my answer start at? X cubed minus 4x squared plus 3x minus 1. What is this? Okay, so there's some books that'll put like a line there or a block there to show the separation. You do want to have the 0 there to show that it's a factor of. The remainder is 0, so I know it's a factor. Okay? So these get to be oh so much faster. I want you to do this one. I'm going to do it longhand. Go. That color. I know. I told you to do it by synthetic. I did it by long because I want to point something out. Now, if I go synthetic, 10, -13, 5, -14. with a 3/2, right? The 0 of.
Yeah.
Okay. And color. I'll do that. Okay.
Do you want us to like simplify it? 'Cause, like you can't.
We're getting there, but it's not simplifying. Okay. Like there's a reason. Half of 10 is 5. 5 by 3 is 15. Half of 2 is 1 times 3 is still 3. Add them together, get an 8. Half of 8 is 4. 4 by 3 is 12. I still get a -2. Why does this one end up with, squared? Why do they end up differently? Because. Okay. When you found the 0, you divided by 2. So if you divided this by 2, you divide this by 2. 5x squared plus x plus 4 minus 2 over 2x minus 3. That's it. Like, that's the thing. Notice everything that we've done so far, it's always been x minus 4, x plus 6, x minus 5. X was always 1 as a coefficient. In this case, because I had to divide by 2 to make my 0, I also need to divide my quotient by 2. You don't have to touch the remainder. The remainder takes care of itself. But that is something super important. I tried to stress it in my Algebra 2. If that is news to you, get that highlighter and make a point of this, because that is a big deal. You can do synthetic division with ugly things like this. You have to remember that if there's a denominator here, you have to divide your quotient by that denominator as well.
So if we divide our quotient by the denominator as well, does the remainder get divided as well?
The remainder takes care of itself. You don't have to touch the remainder. Yeah?
So could we do it? I was thinking like you divide like the 10, 13, 5.
You can. No, you can. It's gross. Because you're taking your 0 and dividing by 2, technically what you're supposed to do is also take your dividend and divide it by 2. Okay?
The first 5.
Yeah, that's like it's printed. But now it's going to be, right? And disappointment. Oh. Okay. If I take 3/2 times 5, I get 15 halves. 13 halves plus 15 halves is 2 halves. It is 1. 3/2 times 1 is 3 halves. 3 halves plus 5 halves is 8 halves, or 4. 3 halves by 4 is 12 halves. Negative 14 halves plus 12 halves is negative 2 halves is negative 1. 2. 2 words. No. No, it's negative 1. Okay. So, then you have that oddity of, I got all the right stuff here, but since I divided my dividend by 2, I need to now double my remainder. So it's either do it normally and divide this stuff, leave the remainder alone, or divide all of it, but then you'll have to multiply your remainder. Like, it's do a right turn and then a left turn, or a left turn and then a right turn.
Or
They're the same thing. Yeah.
or you could put -1 over x minus 3 halves.
Yeah, that's why, because when I take this, now it's 5x squared plus words x plus 4 plus -1 over x minus 3 halves. That's why you have to then multiply it by 2. I don't know too many kids who want this. They would rather write this, but you're right. I would take this. It's correct. Okay, so it's something to be aware of that we didn't stress very much in Algebra 2 because it didn't happen very often. Go. All right, can't do it anymore.
Well,
Been a nice run, guys.
can one of us go for board meeting today?
Yeah.
I kind of want
Someone be great.
I kind of want to go do it on board.
Ashley,
Wait.
why'd you have to ask Ashley?
Alright,
Let's go in. Let's go. What color? What are we going with?
That's not gonna show up as red.
Whoa, that's wild.
It's inverted, you have to go to the marker.
What?
Yeah, go to the marker on the left side. There you go. Click on it. There you go.
What color should we go?
Go white. Do it like you guys.
Okay. First, 3x equals -1.
The teacher.
Wait a minute. Correct?
Yeah. Professor Andrew up here.
Taylor's gonna be watching the stream and just like.
-12.
What?
-12.
That's a brownie point. Drop the 6 down. We get that -2. Am I correct?
What?
9. And then we have multiplied that by -1/3 is 3. Drop that down. That's -12.
I'm 100%.
-1/3.
What'd you guys do?
That's 4. Add that. That's -8. Multiply that by 1/3.
Isn't it a negative 3?
What?
It's negative. Under your 15. Yeah, it's a -3.
Yeah, I did that too.
Which changes it.
Good catch. That's another brownie point.
Wait, so you gotta make sure before it's 2
2 x plus
Thanks, Paul.
squared minus 6 x squared minus 2. Oh,
Yeah.
x.
Put your marker down.
Then it is minus 2x.
That's what I'm trying to figure out. I'm at the point that everyone can do.
Okay. 18.
6 squared 6.
Math. Is that 6? 6. Drop that down to -6.
Hold on, hold on one second.
I think
2.
Minus 6x.
Yeah, you got
9.
minus 2.
Wait, is the
Oh, wait,
number
I
or is the number?
You do anything with.
Alright.
That's
Now we divide everything by 3. Because we divided the original answer,
Except for the remainder.
right? We divided all this by 3.
Yeah.
So, we divide everything except for the remainder by 3, correct? 2 x to the third
Oh no, it's
3x squared minus 9x.
It's 6x.
What?
18 divided by 3 is 6.
Eddie, you cannot be.
Thank you. That's another brownie point.
Write it up to do it.
No, you have the
6x
kid's name up there.
minus 3.
We have got.
And then we have 9.
Yeah, that sounds like 5.
Where do you have-
Wait a minute, yeah.
Oh no, it's 5.
No way.
Add another one on there, like at least 5. You can't have
Yeah, we got I'm getting a point.
negative 4.
Andy, that's a 2.
And
That's
at this point, you need about
Yo,
5.
What are you talking about? This one. That's supposed to be 2, not 3.
And then wouldn't it be plus no?
But it's an easy job, right? You just look at the teacher's edition.
Wait, hold on. Don't forget about the plus between the 2x cubed plus the 3x.
I think I did a pretty good job.
Okay. But would you agree that it's probably easier to just run it like normal and then at the end divide by 2?
Yeah.
Or 3? Okay.
It's just gonna be me up there silently working. She's not gonna hear anything.
Well, the mic was right there.
Oh, was it?
Well, I ain't bringing it with me. Be like, okay, you're never going to see it because y'all are too young. There's an old episode in The Simpsons that they don't air anymore because they went to New York sightseeing and they go to see the World Trade Center. So Homer, like they show it from the back view here, Homer has to pee. He gets into the lobby and it says, go to the 98th floor or whatever because all bathrooms are out of service. And you hear, he gets there and there's a sign on it that says out of order. And so, and then you hear what sounds like Braveheart. Freedom!
I stopped when the girl died. I was like, it'll be great.
Do you really want that? Do you want me to bring this with me? Because I just sucked down a Mountain Dew in 20 minutes?
We didn't know what we were doing, so
Tank was full, dude. I'm out of here. No.
my manager said that the other day and she was left. So we didn't know.
Oh, yeah, I'm just like, screw it, you teach. Okay.
I know, I thought we were
Don't worry, I asked.
All right. The actual remainder theorem.
Oh, so we're not.
So everything, no, you know how to do synthetic division. You're fine. Okay. The actual remainder theorem says, every time I do this synthetic division thing, I get stuff. And what happens when I hit 0 at the end? There's no remainder. There's no remainder because it's a factor. It's a factor, therefore there is no remainder. It's a biconditional, right? So someone takes that and they say, well, wait a second. If it's a factor, then it's a 0. It's called a 0 because it hits the x-intercept. So if I were to take the function of that value, I would get 0. Right? Like if I have x minus 3 and I do all the and get 0 at the end, that means this is a factor. If this is a factor, then x equals 3 is a 0. So then if I say the function of 3, what should happen? I get a 0. And old famous dead dude says, wait, does that work for everything? And he tries it, and sure enough, it works. Whenever you do synthetic division, your remainder here is if you had plugged that number in, which allows you to do evaluations of functions a lot faster. That's the actual remainder theorem. So let's say you have an absolute dork of a teacher, maybe they teach math, and they decide to make a function to denote the number of games played in football tickets. Because, you know, math teacher's gonna math teach. Says number of tickets sold is this cubic. X is the number of games played. Use remainder of theorem to find the number of tickets sold during the 12th game. What number goes where? You plug in for X, like number of games. Y'all got a calculator. T of 12 is 12 cubed minus 12 by 12 squared plus 48 by 12 plus 74. Well, that's just going to cancel. 48, 12, 144, 4, 400, 576, 74, 580, 7650, question mark?
That's what I got.
What did I do wrong?
Okay. So, because the first two cancel out, 12 cubed and then 12 times 12 squared.
Okay, I was gonna say that.
I just canceled that out. So, I can do that. Or, remainder theorem can make it go faster. 1, negative 12, 48, 74. With 12. Go. 12 by 1 is 12. Negative 12 and 12 cancels, just like these did. 12 and 0 is 0. 0 and 48 is 48. 12 and 48 is 576. Plus 74 is 650. It's a different and usually faster way to evaluate functions. Go for the 13th game. Yeah. 61 by 13 is 610. 180 is 790. Is 808. 74. 812. 882? Ah, Samsonite. Lost it. Because that's 610, 180 is 790. Oh, 793. That's why. That's why. Okay. And then 867. Okay. So that's what remainder theorem is. When you do this, there's a little note at the top here. Right there. Okay. It's also called synthetic substitution. You'll hear it both. Okay? If they say evaluate using the remainder theorem, then actually use the remainder theorem. If they say evaluate using synthetic substitution, means you do synthetic division and the remainder is your answer.
remainder theorem and synthetic substitution?
That's why I have them there, because they're synonymous. The remainder theorem is the actual theorem that says, if you do this, this happens. Synthetic substitution is what you're doing.
Oh.
It's important to note that in synthetic substitution, in the remainder theorem, you don't change the sign. You don't find the zero of a thing. You notice here we just put in 12, not negative 12. We put in 13, not negative 13. So if they say find f of 5, just put in 5, not negative 5. Okay? It's a small thing, but we all know that changing a single sign can screw you over pretty bad. Okay? Show me thumbs. Can you do that? Synthetic division. We got it? Okay. Then, the factor theorem. The factor theorem is an extension of remainder theorem. If I do synthetic division and I get a 0, there's no remainder. If there's no remainder, then the divisor is said to be a factor. That's all this is. It has a factor x minus c if f of c is 0. We already know that, but now that we have the remainder theorem, we can say, do synthetic division. If you get a 0, then it works. So when they say use a factor theorem to determine if they're factors, use the binomials that are factors to write a factored form. It means take this and try both of these in it, which is getting into the polynomial thing, right? Here's the big quintic, solve. You would do synthetic division to find out which ones were actually factors. So I'm going to try 1 because it's the 0 of the first guy and say 1 by 4 is 4, 21 and 4 is 25. 1 and 25 is 25. 25 and 25 is 50. Uh-oh, I'm going the wrong way. 50 and negative 5 is 45. 45 and 3 is 48.
I have a question.
Yeah.
How come we don't just do that factor to the front of having factor to the back and factor to the front? Thing.
Because that's one of our polynomial root theorems we get on Tuesday.
Okay.
They're just seeing, okay, before we get to how do I narrow down the choices, I first have to see that this even works. I can do synthetic division to determine if it works. Then come back on Tuesday, how do I take every single possible number and narrow it down so I don't have to guess and check 100 times?
Yes.
Okay? So that's not a factor. Tell me it's not a factor. Get rid of all those and try it again with negative 3. And say negative 12, 9, negative 27, negative 2, 6, 1, negative 3, 0. Yay, it works! Okay? Multiply and add, multiply and add, multiply and add, multiply and add. That's it. Now it says write a factored form. I know y'all hate when I bring English into math, but there's a difference between write a factored form versus the factored form. A factored form means as long as I can write it as a product of two factors, I'm right. The factored form means to bring it all the way down to linear factorization. So in this case, I found out that was a factor. I can now say x plus 3 times this. What is this? Right? It was x to the 4th, and I divided it by x to the 1st. So I now have 4x to the 3rd plus 9x squared minus 2x plus 1. This. Right? That is a factored form. Could I keep going with the cubic and find more factors? Yeah, but it doesn't say find the factored form. It says find a factored form. Okay? So, same thing, but I also want to show you, this is leading into that find all the zeros business. If I take 2, -1, -41, -20, and we factor by, just yell at a guy, why don't you? If I use a -4, 2, -8, -9, 36, -5, 20, yay, it works. Side quest, if I say 5 times 4 times 3, what is that? 60. If I take 60 and I divide it by 3, I'll get 20, correct? Doesn't it still have the 5 and the 4 in there? So that means if this is a factor and this is a factor, then I should be able to take this divided by this, and that's still in there, isn't it? So I can just keep going. I don't have to restart the problem. I can just keep going and say, well, there's 10, there's 1, there's 5, there's skadoosh. Right? If I take 60 and divide it by 5, there's still a 4 and a 3 in there. I can now take the 20 divided by the wait. I said that backwards. You know what I mean. So now it says write a factored form. Well, I just found out 2 of my factors. So I'm going to say x plus 4, x minus 5, and 2x plus 1. This, because they're all linear factors, this is now the factored form. Because linear factorization. Okay? Can y'all do the thing? So I don't knock everyone out on the notes. Just give me a big old check mark that says, yeah, we know I do this. Okay? Oh, I enjoy several of you have your, flipping through the notes and I see a section that says, we good, homie. So, do whatever you're going to do. If you say something